Now that we have all the experience from implementing the reverse method, let's go one step further. We now want to write a method that will be checking whether a particular string is a palindrome. And S is a palindrome if S reads the same backwards and forwards. For example, consider the word Anna. It will read exactly the same from right to left as it will from left to right. There are also corner cases that you should take into consideration. For example, a single letter. If we think of it as a word, then it is also a palindrome. It reads exactly the same one way or another. Like always, implement this yourselves, and then we will come back together to see and resolve any kind of questions you may have. You see that I have started adding to the file that we also wrote the reverse methods in, since all of them are actions manipulating a string. Another reason that I have added the palindrome versions, as you can see, we have already started 2 of them in the same file as reverse, is because there is one way that we can connect the implementation of one method with the other. How can we find out if a particular string is a palindrome? If we have the implementation of reverse, which we do right now, a straightforward way, the easiest way, is to do the following. Take the string, compute the reverse string, and figure out if the 2 strings are exactly the same. And how can we compare the 2 strings? Like we have said many times, it will not be through the double equals operator, but it will be through the equals method. So here is the implementation of isPalindrome using the reverse implementation that we have already written down. And again, this is pretty straightforward. Now, if we had not implemented reverse, then it is probably not worth it to implement reverse and then isPalindrome using reverse. There are different ways that we can implement isPalindrome, and this is what we are going to do inside the second version of this method, isPalindrome 2. Let's think about it. What does it mean, again, that a string is a palindrome? It reads the same from left to right as from right to left. So if we examine this string, one way we can figure out whether it is a palindrome, it is to examine pairs of characters. We will compare the first letter with the last letter. Are they the same? Yes. If they are, then we will go one step in. The second character with the second character before the last. Is this pair the same? If, for example, that pair was not the same, then we are done. We are just going to return false. I brought up this picture that you may find useful in order to understand the algorithm according to which we are going to check whether the string is a palindrome. And what is that? Again, here we have assumed, for example, that we have a string of 5 letters. We're going to be checking pairs. So first, we will check the first character and the last. If they are the same, then it is meaningful to go and check one pair inside, the second character with the character before last. If that is again the same, then it is meaningful to go and check further inside. However, if this last pair, for example, were different words, it was the character A and the character B here, for instance, then there would be no point into continuing the comparison towards the middle of the word. We could just figure out and say, no, it is not a palindrome. Time to code our algorithm then. We will want to examine all of the string, and since we know the length of the string, sounds like a for loop will be appropriate. What do we want to do inside the for loop so that we know the conditions also? We want to examine at every iteration of the for loop, we will be examining the character at the first position, whether it is the same as the character at the last position. And first and last positions will be the ones that we will be checking at the very first iteration. So this one will be 0 with s dot length minus 1. This is why autocompletion is good, so that we don't have to write it many times. So here we want, the very first iteration, we want to check first character with last character. Now on the second iteration, we would like to check the second character with the character before last. Of course, if the string has two characters. It could be a case that the string only has one character, and so the condition will have to take into account that, so that we don't loop after we have reached the end of the characters of the string. So one way we could implement this would be to say I will have one variable that will start from 0, and it will be the variable that I will be using from going from left to right, and another variable that will be starting from the very last character and will be the variable going from right to left. And at every iteration I will be checking whether the character at I is equal with the character at j. Before we go and fill in the condition of the for loop at this space here, we will need to make sure that we increase I at every iteration while we decrease j at every iteration. So this is a for loop where we're using two control variables. We're changing the values of two variables instead of one as we usually do. Again, there is a missing part here that we need to make sure, and we will come to that in a bit. Before that, what is the condition that we want to check? Here it is. Here is the condition. And what should we do if we find out that these characters are the same? Well, we just need to keep on looping. So if this condition is true, we are happy, we want to go back and loop again. If this condition is not true, this is when we need to take an action. And what kind of action should we take? There are various ways that you can think about it. One would be to say, okay, I will have a Boolean variable here. I will call it, for example, is pal. I will not is pal. I will call it, and I will say this variable starts true. If this condition is not met, then I will make is pal false, and then I will be returning the value of this variable, right? And that's what all that we should be doing. Now, having this variable, although it is not incorrect, it's also redundant. We don't really need to do that. And why is that? Because if we find out that there is at least one pair of characters that does not satisfy our condition, we can just at that time return false. And otherwise we will return true. If the loop completes, then we can just return true. In the previous, I should have said also in the previous version with the variable, the is palindrome variable, I should have said that here, instead of making is pal false, we would also need to break from the loop. Right? Now we don't really need that variable, so we just return false. Now you may notice that the IntelliJ IDEA tells us that this statement is unreachable. Why is that? This is the case because for the moment we have not put any expression as the condition of the for loop. And when we do that, it is a rather dangerous technique. When we do that, the condition is as if it is always true. You see, when we have true there, this remains unreachable. In other words, this loop will continue executing forever, so statement 66 will never be executed. However, if you turn this into false, you will see that now this statement is fine. However, this statement is unreachable. Why? Because the condition of the for loop is false, so the body of the for loop will never be executed. So let's go and figure out what is the right condition to have the loop executed. remember that we are checking pairs of characters, the first with the last and so forth. So we don't really want to write here, for example, until I is then less than s dot length minus 1. We don't want to execute it for as long as the word is, as long as the string is. Because we are checking pairs, we only want to go half of the way for I. Because the other half will be the distance that a j will go. And again, you see we are calling s.length here, we are then calling s.length, this is the major problem, we are calling s.length at every iteration of the loop, although the length of the s doesn't change. So what we can do, as we have done before, for example, in the reverse examples, we can have a constant keep the value of s.length and then work around that. Like we did with the reverse again, inside main we have created assertions, the examples that we want to make sure that they work. What are those for the palindrome, for example? And you see I have repeated them for both versions of the is palindrome. We want to check characters, that should always be true, or if we have one character next to another, just a string of length 2. We also want to make sure we check false conditions like x, y, and henway, and of course larger words, longer words. But pay attention to the fact that we are also checking corner cases, like what if the argument to the method is the empty string, or what if it is a string that is null? If we execute the program as it is, you will see that we will get null pointer exception, and where is that? It is because we're calling s.length at which test case? At the test case that is testing null, which is what we expected. The null pointer exception is when we are calling a method like length on something that is null, in this particular case s. So the way that we would solve that would be the same as in previous examples. We can say that if s is null, at the very beginning we say that before any s dot happens. If s is null, then return, for example, true. This is a judgment that we will have to make depending on what exactly we want the method to do when it takes a null parameter. It could be, for example, that we should be returning false. It is really up to the application. And so that we are more confident that this actually works, let me just run it again and see that now no compile or runtime errors happen.